All right, now we're going to finish up our cramming versus spaced practice analysis. The next step is to calculate Cohen's d. Now, if you remember the formula for Cohen's d, the one that I use on my formula sheet is a little bit different than what's in the book. It works just as well. What we do is we take the difference between the two means, mean 1 minus mean 2, and we divide that by, it looks a little complicated, but we just take the squared standard deviation for group 1, add that to the squared standard deviation of group 2, there we go, divide by 2. So we're basically taking the average of the two squared standard deviations, and we then have to square root that because we squared these in the first place. So up above, the difference between our two means was 8 points, so that's the top half. And in the bottom half, I'm going to put the standard deviations were 7.7 and 7.79. So 7.7 squared plus 7.79 squared divided by 2, right? We're just averaging those two together and taking the square root. So I'm going to plug that into the calculator. We're going to take, there we go, 7.7, square it, add that to 7.79 squared equals, then we have to divide that by 2, and we get 59.99. And then I have to remember to take the square root of that, which is 7.75. So now we're left with 8 divided by 7.75. And so 8 divided by 7.75 equals 1.03. 1.03 is Cohen's d, and that is a very large effect. Our sample means were about 2 standard deviations apart from one another. Okay, that's Cohen's d. Next up, we have our confidence interval. Now, the formula for the confidence interval, CI, is the difference between the two means, okay, mean 1 minus mean 2, and then we're going to add and subtract that from the standard error of the mean that we used in T, which was 3.46, 3.46 times the critical value of T. Okay, critical value of T, not the T that we calculated earlier, but the value that we looked up in Appendix B. So times 2.1009. So our difference was, we had 8, the difference between the means, and we're going to add and subtract that to, if we take 3.46 times 2, try it again. 3.46 times 2.1009 equals 7.27. So if we first add those together, we're going to get an upper bound of 15.27, right? 8 plus 7.27. And we're going to get a lower bound, meaning we subtract 8 minus 7.27, and that comes out to be 0.73. What does that mean? Well, our samples differed by 8 points. Okay, the exam scores differed by 8 points. We are therefore 95% sure that because of sampling error, that the actual difference, if we were able to test the whole population of everybody who crammed compared to the population of everybody who did spaced practice, is somewhere between about 3/4 of a point and 15.27 points, right? That's our margin of error. The actual population difference is somewhere between those 2 points, okay? We got an 8-point difference. the actual difference is somewhere in there. So now we've completed the whole analysis. We see that there is a significant difference between the two means, which means we believe there's a real difference between cramming and spaced practice on exam scores. And if we look at the actual means, we see that the spaced practice, it has the advantage, that this is a better way to study. We also know that the difference between these two study approaches is quite large. It actually leads to not just a significant or a real effect, but a large effect. And then lastly, we know if we were able to test the population, there's a 95% chance that the actual difference between the two populations would be somewhere between almost a point and 15 points in exam scores. So that completes an entire independent samples t-test, including the significance test, the effect size, and the confidence interval. I hope you found that helpful. Let me know if you have any questions.